We've already seen the idea of streams, but how does Node deal with streams, this concept? And again, a stream is really just a sequence of pieces of data that's broken up into what's called chunks. Big word alert. A chunk, a piece of data being sent through a stream. So we take our data, we take our information, split it into chunks of some particular size, and send them down the pipeline between whatever 2 points of communication we're trying to send the data between. And sometimes you'll even see the phrase chunk, or someone named their variable chunk, in code that deals with streams. The best thing to do first, though, is to take a look at streams inside the Node.js core on the JavaScript side, the stream.js file found inside the Node.js source code. First of all, the thing that's exported from this module is the stream constructor. But we notice something. There is an event emitter that's grabbed, and stream inherits from event emitter, and this could easily be a class extends as well. But in either case, streams are event emitters. That's really important. Remember how we said that many components inside Node are actually built on top of the event emitter in that construct? Well, here's an example. So any streams that are created have access to methods like on and emit. They have that idea of an object which contains an array of functions that can be invoked whenever we say that something has happened. However, there is an old stream code and there is the new stream code. There used to be just streams, but now there's a variety of types of streams. A readable stream, defined in _stream_readable.js, and these various ones you could also take a look at. A readable stream, a writable stream, a duplex, a transform, a pass-through. What are those? Well, they are, for the most part, what they sound like. A readable stream means you can read the data, but you can only read the data that's coming through. You can't send any data back down the stream. And a writable is the opposite. You can send data to the stream, but you can't read any data from the stream. A duplex lets you do both, read and write. And a transform lets you change the data as it moves through the stream. So it's written to the stream and is different when it's read. All right, so that's just an example of some of these things, but the core idea is that you have types of streams. And if we were to go and look at, for example, a readable stream, _stream_readable, I'll see that this readable constructor actually inherits from stream. So that means that readable is a type of stream and also a type of event emitter, since stream is a type of event emitter. And there's one more piece of important information. If you go and look up streams in the Node.js documentation, streams are merely a base or abstract class. Big word alert. An abstract class, and it's also a base class. You'll see it sometimes used somewhat interchangeably, though a base class doesn't have to be an abstract class in all cases. But what the idea is a type of constructor you never actually work directly with, but you only inherit from. So in other words, when we create new objects of this type, we never directly go, give me a new stream. We always build some kind of custom version of it. We inherit from it, and then we make objects from that. Streams don't implement certain methods that are needed in order to actually use them. They implement the base of the idea of a stream, and then it's up to us to decide how we're actually dealing with reading and writing information. This turns out to actually be really powerful for us to build our own streams if we want, but there are plenty of streams out there available built for us of different kinds, including within the Node.js core itself. Let's take a look at the prototype chain then. We understand that we have the event emitter, which the prototype has things like on and emit. And we've seen that a stream inherits from event emitter. And we have different types of streams like readable, or writable, duplex, or transform that inherit from stream that may have methods like read or write. And then, since those are abstract, we never work with them directly. Instead, custom streams for particular purposes, like dealing with files or databases or sending information over the internet, are built, some of which are inside the Node core. And we can build our own. There's actually documentation for implementing your own stream in the Node.js documentation. But the idea being that once we have our custom stream, whatever type of stream we're dealing with, it has available to it all of this functionality, including the ability to emit and listen to events. And there are some events that are emitted. We'll see that in a bit. And to have clear the idea of writable and readable, we can imagine a stream of data. And so Node, as a process, if the stream is writable, then Node could send information to the stream. Or if the stream was readable, then Node could read information from the stream. And if it's both, it's duplex. And if it was changing the data on the way, it'd be transform. But when we say writable and readable, it's important to remember and realize that we're talking about writable and readable from Node's perspective, because these are streams of data. Somewhere on the other end, someone else is reading or writing as well. So in our example of the client-server model, like the web server running Node and the browser, if the browser makes a request of the web server and Node responds, which we'll see a bit later in the course, then the request from Node's perspective is just readable. Even though the browser wrote to it, it's the one sending the information. But from Node's perspective, it's only going to read the request from the browser. It's not going to write to that stream. And from Node's perspective, the response back from the browser, or to the browser, is writable, not readable. It's just sending information. But the browser is going to read it. So when we say readable or writable streams, it's not that they're truly physically only able to be written to or read. But from Node's perspective, this abstraction of this concept, it can only write or read to the stream. Since streams are abstract, we never work directly with them, we need to look at a concrete implementation in order to actually try this. The perfect spot to try this out is fs.js. We've already seen this when doing synchronous and asynchronous file operations. But here, inside the fs module, the files module, there's a function called createReadStream. It takes a path to a file and options, which is actually an object, and so becomes a name-value pair of options for different types of options that will affect how the file is read and returned. But what it does, it returns a new read stream. And readStream is a constructor that inherits from readable. So readStream inherits from readable, readable inherits from stream, and stream inherits from event emitter. So a read stream is a specialized type of read-only stream. And if I was to scroll down a bit, I would find a lot of code to deal with what it's going to actually do, open and read a file. So it implements the part where it actually figures out how do you get data, how do you work with data. But the stream underneath it, where it's inheriting from, gives us the core to work with. So let's try using it. For starters, I'll need a fairly big file, and what I did was did a search for lorem ipsum on Google. Lorem ipsum is just basically filler text. And so I found a generator. There's a few of these, and this one actually let me decide how many bytes or words or paragraphs I want to generate of random text, and then when I generate it, it gives me that random text, and I can generate paragraphs and paragraphs of random but interesting looking data that looks like words that are separated by spaces and are the appropriate number of letters per word. All right, so I used lorem ipsum to generate a greet.txt file, and a fairly good-sized one. If I look on my file system in Windows, I see that greet.txt is about 61 kilobytes in size. Now, a kilobyte is 1024 bytes, and a byte is 8 bits, so that's a lot of bits. But that gives me a file big enough that I can mess around with it a bit to understand streaming. I'll start by going and getting the fs module with require, and then I'll say fs.create read stream. I'll go ahead and use __ dirname / greet.txt, and I'll want to actually have this give me that read stream object that comes back from here. And because it has event emitter down the pipeline, I can listen to an event. And if you look in the documentation, an event that's emitted by the read stream is data on data. So what happens is, and I'll add my listener, what happens is the stream will fill a buffer. And so it will begin to read this file, and it will fill up the buffer with the contents. Now, if the contents are the same size or smaller than the buffer, then you'll just get all the data. But if this text file is bigger than the buffer size, you'll get pieces of the text file at a time, where each piece is the size of the buffer. So it will read some of the text file, fill the buffer, emit a data event, run all the listeners, then keep going, reading the rest of the file until it fills the buffer, then emit a data event, and that will invoke all of the listeners and keep going until it finishes the file. And every time it emits the event and runs the listeners, it will actually pass the data that was in the buffer to the listener. So I could go ahead and console.log this. And if I run this, I see that I'm getting the entire buffer, and I only got one because, as it turns out, a file stream is a fairly large buffer size, by default 64 kilobytes, but it was enough to get the entire data that I had in this text file, as it turns out, here on Windows. So in order to, first of all, get strings instead of buffers, I can specify options, which is an object. So I could say encoding, tell it the encoding. That will tell it, well, you can now take that binary data and figure out what letter each one should be. So I'll run it again, and there. I got an awful lot of text, my entire text file. Now, what am I actually getting? Well, I can look at the string length, run it again, there. So it was slightly smaller than the buffer, it turns out, once it actually pulled all the data in off of the text file. The raw text itself was a bit less than 64 kilobytes. So how can we try to make this show what's really happening? Well, there's actually an option called high watermark. And this is actually the number of bytes that we want our buffer size to be, how big we want each chunk to be. Well, we said kilobytes was 1024 bytes. So to make my life easier, I'll say let's try for 32 kilobytes. So I'll just say 32 times 1024. Since this wants bytes, I want 32, and this is bytes, 1024 bytes per kilobyte. So this is 32 kilobytes. All right, so let's run that, and we'll just see the length. There. See the two chunks? 32 kilobytes, and then the rest. And I could shrink down my buffer and say I want each chunk to be at most 16 kilobytes. There. I got my event, my data event 4 times. The stream emitted 4 chunks, and I could process them. And I just got this length again because this is a string, because I encoded it in UTF-8, so chunk itself is a string. I could show that if I just output it again. There's the string, but this time it actually did 4 console.logs to get the entire string. Now, how can I use this? Well, I went ahead and made an empty file called greetcopy.txt. And what I'm going to do is create a different stream, a writable stream. That's available via fs.create, you guessed it, write stream, in particular when dealing with files. And then I can say what file I want to deal with. I'll copy and paste this, but be sure to change this to copy. I want to write to the greetcopy.txt and read from greet.txt. And so this will create a writable stream. So what I can do then is on every chunk, I can just say writable.write and send that chunk to the write stream. And since it's a file writing stream, when it receives that chunk, it will simply write it to the file. Make sense? So on every chunk, this will happen. And you may be wondering what starts the actual process. Well, in this case, just listening to the data event actually starts the stream reading. But I have my string, and I send my string to the writable stream. I read from the readable and write to the writable. And so what should happen when I run this is it should take the contents of greet.txt and copy it to greetcopy.txt, one buffer size at a time. It ran, and there it is. I just copied the files by listening for the data event, because a stream is an event emitter, and sending the data to the writable stream, a piece at a time. And that also means I didn't need a massive buffer in order to work with the file. I didn't need to read the whole file in at once. I could send it in pieces and minimize the amount of memory that my program, my application is using on the server. Make sense? Now, this is a very simple example, but it is the core of readable and writable streams. However, this little piece that we did here of listening for the stream to send data and then writing it to the other stream, that's so common that there's actually an even faster and better way to do it within Node. And we'll take a look at that.